Find the equation of the plane passing through the 3 points. So all that we are given here are 3 ordered triplets. So let's label these points. We can say we have point A, which is the ordered triplet, 1, 0, 3. We have a point B, which we'll define as 0, 4, 2. And we have point C, which here is 1, 1, 1. And that's it. That's all that we're given. Well, what is it that we want? Well, we want the plane. So we want the equation of the plane passing through these 3 ordered triplets. So how are we going to do this? So let's just keep in mind real quick that we know the equation of a plane in R3 is defined as A times x minus x naught plus B times y minus y naught plus C times z minus z naught is equal to 0. And that comes from the dot product of those 2 vectors that are normal to each other, where P naught is a point on the plane, and the vector n, so this is the vector with the components a, b, c, is a normal vector, a non-zero normal vector to the plane. So we need, in order to find this equation of the plane, we need a point P naught and a normal vector. So finding P naught is easy. We already have 3 points on the plane. So to define or to find P naught, simply choose one of the 3 points. All of them work. But we only need to choose one of the given points. So pick your favorite point. So let's go ahead, we'll just let it be the first one. Let's let P naught here be the ordered triplet 1, 0, 3. But again, B or C will also work. Now how are we going to find a normal vector? So let's pause for a cause here and think about an illustration of our plane. So here is a beautiful piece of a plane. So here is this wonderful plane. Of course, this is just a small region of it. It extends infinitely in all directions. And we know that this plane contains these 3 points A, B, and C. Now for simplicity, I'm just going to put them right on these corners. So we can say that this here is our point A, here is a point B, and here is point C. And they, again, could be anywhere on this plane. So how can we find a normal vector using this? Well, let's recall, we can define 2 vectors that are parallel to the plane using these ordered triplets. So we can see that this vector here, AB, and this vector here, AC, they're both parallel to the plane. Now, if we take the cross product of them, we're producing a vector that's normal to the plane. So if we cross the vectors defined by these ordered triplets, we produce a vector that's normal to the plane containing these 2 parallel vectors. So that's what we're going to do here. We are going to need to find, first of all, we need the vector AC and the vector AB, and then we'll take the cross product of them. So here we go. Vector AB, again, terminal minus initial. So this is going to be 0 minus 1, 4 minus 0, and 2 minus 3, which leaves us with the components -1, 4 minus 1. And similarly, we want to go ahead now and find the vector AC. So again, terminal minus initial. So I have 1 minus 1, 1 minus 0, and then 1 minus 3, leaving us with the vector 0, 1, -2. So these 2 vectors are parallel to the plane, and we'll take their cross product to find a vector that's normal to the plane. So we need a little bit more room. So here we go. We can say that our normal vector is going to be defined as the cross product of vector A with vector AB with vector AC. So putting these two vectors into that 3 by 3 determinant, we have the first row of our standard unit vectors, I hat, j hat, k hat. The second row has the components -1, 4, -1, and the third row is 0, 1, -2. So by definition of the cross product, we have 4 times -2 is -8, minus 1 times -1 is -1, I hat, minus -1 times -2 is 2, minus 0 times -1 is 0, j hat, plus -1 times 1 is -1, minus 0 times 4 is 0, k hat. So we are left here with, we have -8 plus 1 is -7, I hat. We'll have a -2, j hat, and then minus k hat. Now, this is not an exclusive solution here. You want to keep in mind that how you define your two parallel vectors will determine the components of your normal vector. So we have everything we need. We have the vector that is normal to the plane, and we have selected one point here as our p0 value. And so we're all set and ready to find the equation of the plane. So here we go. Again, we'll start with our dot product here. We have x minus 1, y minus 0, z minus 3, so our position vector, and we dot this with the normal vector we just found, -7, -2, -1. So these two vectors are perpendicular to each other, so we know that their dot product is 0, and by definition of the dot product, we have -7 multiplied by x minus 1, minus 2 times y, minus 1 multiplied by z minus 3 is equal to 0. And we're ready to simplify. We'll distribute these coefficients through and then group up our like terms. And let's give ourselves a little bit more room. So here we go. We have -7x plus 7 minus 2y minus z plus 3 is equal to 0. And we can add up our coefficients here. 7 plus 3 gives us 10, leaving us with a beautiful final answer. -7x minus 2y minus z is equal to -10. Or you can divide both sides by -1 and write your answer as 7x plus 2y plus z is equal to 10. And this is our beautiful final answer of the equation of the plane determined by those 3 given ordered triplets.